Hello everyone. In today's video we look at elementary programming concepts in Java. As usual, we're going to try and stay close to what's in our textbook, and today's video will be corresponding to what they cover in chapter 2. Essentially it's variables, how you declare and use variables, and mathematical operators. Okay, we start by looking at the solution of a simple problem. So we're going to take a look at an example first, and then we're going to go on and look into the individual concepts one by one. So what's the problem? The specification of this problem is we need to compute the area of a circle. And what you're seeing on this slide here is what a lot of people would call pseudocode solution. So it's you're using a language that's close to English to describe the solution of the problem. And this looks like a redundant step, but actually in real world situations this would help you save time because it allows you to control and perhaps even eliminate all logic errors in your code. So you're coming up with the solution and expressing it in simple English. As soon as you're done with this step, all you really have to do is just translate it into valid Java syntax, and you got yourself your code. So the problem here is asking us to calculate the area of a circle if we are given the radius. How do we compute that area? The formula says that we need to multiply the value of pi by the radius squared, so pi r squared. What do we need to do in our code? We're going to need to read the circle's radius from the keyboard. We then use the mathematical formula that we know for calculation of the area of a circle, and then we finally display the result. And here's the Java solution that corresponds to this pseudocode. Let me grab that, maybe copy it, paste it into my JGrasp IDE editor. I need to create a new Java file first. Paste all that in, and I will be able to test it. Let's take a closer look at the code here. So we already know that the entire program needs to be one class, and we can call that whatever we want. So this is an arbitrary name, but hopefully you'll be coming up with some good names for your classes that would be descriptive and suggest exactly what you'll be doing with your code. So here we are calling this program compute area. The entire class needs to be enclosed in between a pair of curly braces, and well, at least for the time being, all we really need is just a main function. So public static void main, spelled with a lowercase m, is how we create the main function. It needs to be publicly accessible. You should be able to run this method without the need for instantiating the class. We'll talk about classes and objects in a few weeks, but this really just says there's no need for classes or objects. I want to be able to run this program as it is. Void means the method is not expected to return a value. And then main is a reserved name for this method. What we have next is a list of strings, which represents the arguments passed along to this program when we run it from the console. We're not going to be having any arguments here, so we're not going to be passing anything to it, but this still needs to be there just in case. It's the correct syntax for this method. So going down to the next line, all of these statements will be executed in sequence. We need to declare a couple of variables. Can we solve this in a different way? The answer is yes. There's always more than one way to solve a problem. However, in this scenario here, we believe that two variables are going to suffice nicely. That's really all that we need to be able to store our data in memory and produce the result we're looking for. So radius and area are the names of our two variables. You can think of variables as memory locations that have names. So radius is going to be pointing to a memory location where we'll be saving the value for the radius. And area will be pointing to a memory location where we'll be saving the computed value for the area. There's a set of primitive data types that exist in Java and in most other high-level languages that you can use, and double is one of them. It allows you to store a floating point or a decimal value, so one that has an integer, a whole part, and a decimal part. And we're going to be looking at all the primitive data types in a moment. So we are declaring here both variables to be of type double. Nothing has been assigned to them yet. So please keep in mind that once you declare your variables, before you use them, you have to make sure you assign something meaningful to them. So currently radius and area have nothing assigned to them. On the following line, we pick a value for the radius, in this case just an arbitrary value, 20. In just a moment I'll show you how you can read values from the keyboard, so you can ask the user to provide those values for you. So we initialize the value of radius to 20. Now the way the assignment operator works is you're always going to have a variable on the left hand side, so just a single item, and it's going to be a variable, something that you can change the value of. And then on the right hand side you're going to be having either a constant or an expression or a function call that evaluates down to an expression. So something that will produce a single value that you can then take and assign over to whatever variable is on the left. So here we take the value of 20, it's just a single constant, and we assign that to the variable radius. On the following line, and you can see here that I'm ignoring the comments. The comments are really just for us to tell us what we're doing there. The compiler will be ignoring all the comments when it compiles the code. So on the next line, we take the mathematical expression that allows us to evaluate the area. We multiply pi by the radius squared. An easy way to do that is just do radius times radius. And we assign that value over to the variable on the left. Now we have the area, we're ready to display it. On the final line here, in the final instruction, we take a string, we create a string. So we're trying to be descriptive here, and we're trying to help the user figure out exactly what is going on. Now I can see that this instruction has been split into a couple of lines. Now that's generally a bad idea. You never want to have a hard carriage return onto a single line. I'll be pointing that out to you in class as well, but we're not able to fit that onto the slide, which is why it showed up on two lines. But as a rule of thumb, please remember you always want your instructions, a single instruction, to be on a single line. So over here we got the print line command that takes a string, it attaches the value of radius to it, then it attaches the word is, and then finally it attaches the value of area. It makes one whole big string out of these 4 items. This is called concatenation. So when you're adding multiple strings together, you're concatenating them. We have concatenated a couple of text strings and a couple of values, all with the help of this assignment operator. And we print that out to the screen. I should be able to run this. In JGraphs, you got a couple of small buttons here. The little running guy is actually what helps you run the program. You click that. If you haven't saved your code yet, it's going to ask you, do you want to save it? I say yes. It's smart enough to select the correct name for my source code file. Just make sure you place it wherever the rest of your work is. Click save, and as you can see down here in the output window, it saved the file, it compiled it, and then it produced the end result for the area. Initially, just one final thing I want to point out here with this first example, we're going to be concerned with understanding and learning the functionality of Java, making our programs work. We're not going to be concerned with making them foolproof. So there's a lot of things that can go wrong, and eventually we're going to start paying attention to that, and we're going to try and make our programs foolproof, meaning that we were just trying to anticipate different kinds of input from the user and then handle it accordingly. But for the time being, please do not worry about that. Just worry about the functionality of your code. So making the programs work, do what they're supposed to do. Okay, let me switch back to the presentation here. So that was just a quick intro to what a program could look like with using variables as well as mathematical expressions and the print command. You don't have to do the print line. Print line ensures that the cursor goes on to the next line after you have printed whatever you're trying to print to the console. You can just use print if you like. And if you want to format your string, you can use printf. There's an entire separate command for that that allows you to do some special formatting, particularly to the numbers you're displaying onto the screen. Quite often, so we're jumping ahead here a bit, but we're going to have to do that on a few occasions. You may need to read data from the console. How do we do that? Well, turns out this is one of the things that are not built into the default library, so there's an extra step here. We need to import a package called scanner. So this scanner package has the functionality that allows you to read data and text and numbers from the keyboard buffer, and so we need to do that first in our code. We need to import java.util.scanner, and then the two steps to reading something from the keyboard is the first, it's an intermediate step here. It looks like it's redundant, but it really needs to be there. We create a so-called scanner object. It's just the entity that's capable of handling all the input. So we create a scanner object, we come up with a name for it. Input is a pretty good name. This isn't a reserved word, okay? It's just it's a name for the object, and then we initialize it by connecting it to the default input device. As soon as we have done that, we can use it to read values from it, and the way we do that is by using its name, dot, and then a method, which is going to be one of these methods here on the next slide. Next double simply tells the system you want to read the next value from the keyboard, and it's got to be a value of type double. So we'll be assigning that to the radius. I know you're thinking, how do we ensure that it's a value of type double? Like I said, let's not worry about error handling at this point. There is exception handling in Java, which is pretty good, and it's one of the main topics we'll cover in this class. But for now, when you see something like this, please assume that the user is not going to do funny stuff. He or she is just going to give us a double at the keyboard so we can read that in our program and use it. There is a way for you to read a byte, a short value, int, long, float, double. These are all the different primitive data types. Okay, we'll take a look at them in a moment, but this is just a reminder that there is a separate method for each one of these data types. If you need to read an integer, you use nextInt. If you need to read a double, you use nextDouble. And if you have to read a string, you can just use next. Or if you want to read the string and then clear out the end of line character at the end, there's another one called nextLine. So we will experiment with most of these in our code. We're going to need these in our exercises and our assignments. A word about identifiers. In my other video, I mentioned that the best way to approach this is when you're coming up with names for your variables and your methods, that you should start with a letter and then continue with any sequence of letters, numbers, and the underscore. It turns out Java is a little bit more powerful than that. It gives you a little bit more flexibility and freedom. You can, so this, we gotta be just to be particular about the way that identifiers can be named, we have to say that your identifiers could start with a letter, underscore, or the dollar sign, and then continue with letters, digits, underscores, or the dollar sign, any combination of those. Um, as a reminder here, we cannot use the space. Okay, there's no spaces allowed, no other special characters. These are the only types of characters that are allowed to be in a identifier. Um, and it cannot be a reserved word. Okay, there's an appendix in your textbook that lists all the reserved words. I'm probably going to have a handout, another separate document that lists all the reserved words in Java for you as well, and you can find those easily online as well. Now here's some examples. Compute area, show message dialog, and underscore me are all valid. $2 looks like a literal. It looks like $2, and it's not really a very good name for a variable, but it's not a literal. It's not a value. It actually is a valid name for a variable, and you can assign something to it. That's why I don't quite like the $, and I try to avoid it in variable names. But if you see this on a test or a quiz, this is an actual valid name for a variable. 2a isn't valid because it starts with a number, and that's not allowed. D plus 4 is invalid as well because it's got the plus sign in there, and that's not allowed either. And then radius is a good name for a variable. Alright, a couple of examples of how you can use those variables. Do note that all the variables will need to have a data type and a name. So Java is a strongly typed language. What that means is that all of your variables need to be declared with a certain data type. So the compiler needs to know the data type of your variables before it can compile the code. And that you're not allowed to change the type of a variable. So once you have declared, for example, area to be of type double, it's going to stay of that type, and it's not going to change for as long as it exists in your in your code, wherever you have declared it. So if you create this inside a method, as soon as you get out of the method, it no longer exists. But for the duration of, for as long as that method exists and it's running in memory, area is going to stay whatever type you have defined it to be. And the good thing about variables is that you can retrieve their values as many times as you need, and you can change their values, preserving the data type as many times as you need. So variables are essential to any programming language that should be capable of producing or creating solutions to all kinds of problems. What I mean by that is there are certain constructs that include variables, operators, and the logical structures. We're going to be looking at those in weeks 2 and 3, decision statements and loops. If you have those in your language, then with that language you'll be able to create a solution to any kind of problem, from something as simple as adding 2 and 2 to something as complex as brain surgery. Okay, we saw how we declare variables. This is the syntax for declaring variables in Java. First you specify the data type, and then you provide the name. If you need to have multiple variables of the same data type, you can list them all on the same line and separate them by commas. Some examples down here: declaring an integer, a double, a character, and another couple of integers. Assigning a value to a variable, we already saw that as well. We make sure that whatever is on the right side of the assignment operator produces a final single value of the same data type that the variable has, the one that's on the left side. So here we assign 1 to x. I'm assuming x was declared as an integer. A was declared as a character, so we assign the value of the letter A to it, and so on. This is called inline initialization. I believe that's the correct term for when you declare and assign a value to it, or some people call it just initializing a variable. That means you create the variable and you assign a value to it at the same time. So you're allowed to do that. Quite often in your code, you may need to repeatedly use a value that doesn't change, in which case it could help to give that value a name. So these are called named constants. For example, if you have a program that uses pi repeatedly, instead of using 3.14, a better way to do that is somewhere at the top of your code, you declare a constant with the name pi and you assign the value of 3.14 to it. From that point on, you can just use pi in your code and your code becomes easier to read and maintain. The correct syntax for that is by using the keyword final. So it's like declaring a variable, but you're adding an extra word in front of it, saying final, which tells the compiler that this variable is never going to change for as long as it exists. So you're essentially turning it into a constant. You've probably noticed that these constants here are all spelled out using uppercase letters. This is not mandatory, but it's a good programming habit. For your constants, please make sure that you use all caps when you're naming them. And if they have to be, if their names need to have multiple words in them, you can just connect them with the underscore. The basic primitive data types in Java include byte. You can use that to store integers that aren't very large. So you can see the range here. Your various values are going to go from -128 to +127. If you need to store a value such as 128, for example, a byte will not do because it's outside of the range. So only a single byte is being used to store that value. When you use a couple of bytes, you can store values that are in the range from -2 to the power of 15 all the way to 2 to the power of 15 minus 1. Okay, that's the short data type. Int is one of the popular data types. In Java, they use 4 bytes to store an integer, and you can see here the range is pretty large, but there's still a range, so be mindful of that. One of the common mistakes that beginner programmers make is they use a data type and then try to for a variable that's just insufficient for that variable to store whatever value you need to store. They go outside of range, so this is just one of the common pitfalls for new programmers. Just be careful. If you need to use a large value, make sure you're using a data type that can handle that kind of value. Long is also reserved for integers, but this time you're using, what is that, 8 bytes. So you can see you can store some pretty large numbers with the long data type. Float and double are reserved for decimal values, which means values that have a whole part and a fractional part. The difference between the two is that double uses twice as many bytes to store the values, so you're going to have a lot bigger range, and it gives you better accuracy too. So with the integer data types, values are stored precisely. Okay, you can never end up with the wrong result, or a slightly inaccurate result, I should say. With float and double, we don't have perfect accuracy. Let me show you this. And this is explained really well in the textbook. But, okay, let me delete all this. Now what I want to do next is just do a brief calculation with double values. So 1.0 subtract 0.9 from that. Now mathematically I should end up with a 0.1, but since Java and most other high-level languages don't use perfect accuracy, it's just not possible to do that with floats and doubles, your chances are we're not going to end up with 0.1, so it's not going to be perfectly accurate. Let's see what happens. Compile, run, and here's the result down at the bottom. So it's really very, very close to what I was expecting to see, but not exactly what you would normally figure out to be the end result of this. In mathematics, this would result in 0.1, and that's pretty close to what the result is down here. So that's just something to keep in mind. And these are double values. If you use floats, the accuracy goes down further. Now that's not something that really you need to be concerned about at this point in time. We're not going to end up with incorrect program results. For the purposes of this class, we really shouldn't worry about the accuracy of these data types. However, since this does exist, I wanted to point it out, and I want you to simply keep that in the back of your heads. Usually in our code we're going to be using ints and doubles. Okay, so very rarely we're going to need byte, short, long, or float. Okay, int and double will suffice. If you're using float instead of double, you're saving memory, but we're not really going to be terribly more efficient by doing that. So it's best to just stick to double. And in fact, if you leave the values the way they are right now without any in this example at least, without an f at the end to specify that you're working with floats, the system assumes that you're working with doubles. So that's the default way to handle decimal values, double. Okay, numeric operators, addition, subtraction, multiplication, division, and remainder are the basic mathematical operators. In Java we also have logical and relational operators. We're not going to be seeing those today, but we will be coming back to them, and we'll be reviewing all operators available to us in Java. Today we're only looking at mathematical operators. They work for the most part the way you would expect them to work. So addition adds two numbers, subtraction subtracts second from the first, multiplication multiplies the two numbers. Now with division and remainder, it's a little bit trickier. If you pass along a couple of integers to the division operator, Java assumes that you want to perform the so-called integer division, and you'll end up with an integer as the result. This may seem odd at first, but it turns out there's quite a few situations where integer division could come in handy. It could help you solve problems. The remainder, the percent sign, performs an integer division of those two operands and then returns the remainder of that integer division. So 5 divided by 2 mathematically will produce 2.5, but the way integer division works is you drop the fractional part and you only leave the integer part. Okay, please remember that this is another common pitfall for beginner programmers, and I guarantee you this is going to get you at one point or another, especially if you work with variables. If you have a large program and you're looking at something like x divided by y, and chances are you may forget about the data types of x and y, and if they're both integers, then this is how the compiler is going to figure out the end result of x divided by y, and it may not be exactly what you're looking for. The remainder operation is going to divide 5 by 2, so 2 goes twice into 5. 2 times 2 is 4, and the remainder of this operation will be just 1. So the remainder performs an integer division, and it gives you back the remainder of that division. And this is another operation that turns out to be surprisingly useful. A quick example I can give you here is if you're figuring out the remainder of an integer division by 2, you can figure out whether the number you're dividing is even or odd. So when you do remainder 2, if you end up with a 1, your initial value was odd. If you end up with a 0, your initial value was even. One of many situations where the remainder operation could come in handy. Once again, we're jumping ahead here where the math class which is also one of the built-in classes that are available to you. So unlike the scanner class, which we saw a few slides back, you don't have to import anything. It's the math one is already available to you, and you can start using it if you need to use mathematical operations. The only one we're seeing today is the power function, POW. We'll come back to the math class and we'll explore all the other functions that it has available, but for today we're only going to look at the POW function. The way it works is it takes the first operand and it raises it to the power whatever the second one is. So POW 3 will take 2 and raise it to the power 3. 2 times 2 times 2 produces a result of 8. If you raise a number to the power 0.5, you're essentially taking the square root of that number. So square root of 4 is 2. And then down at the bottom, if you raise something to the power -2, I don't know how long it's been since you've done math. Well, the way that works is essentially the compiler is going to convert this to 1 over whatever this number is to the power 2. Okay, so 1 divided by in the denominator you're going to have 2.5 to the power 2, and that would result in 16. Okay, so that's the power function. Could come in handy. In fact, we could have used this in our first example today, and that's the reason why it's here. Literals refers to numbers that don't change. Really, this is here just a little bit of terminology. So if you see this word literal, what they're referring to is just an actual number that doesn't change. So these are numeric literals that you see here. 34, what is that, million, and 5. Integer literals are numbers that are of type integer. Down here, if you recall, a few moments ago I told you have to be careful about your data types. B has been declared to be of type byte. It stores an integer, but the range of it is from -128 to +127. Well, 1000 is well outside of that range, so this is going to produce an error in the compiler. Floating point literals. So if you want a number to be treated as a floating point number, you have to append f at the end of it. Either lowercase or uppercase f will do. If you want that number to be treated as a double, you can either use lowercase or uppercase d, or just leave that out altogether, because the default data type for numbers that are decimal, that have a decimal part, is actually double. And scientific notation, something I haven't used in my programming experience, but it's just good to note that it's there. It has been implemented in Java. If you like it from mathematics, if you want to use it, that's certainly fine. It's built into the compiler and you can use it. Alright, that takes us to arithmetic expressions, and this is one relatively complex expression up here. I will ensure that we do this in our exercises, and that each and every one of you can handle expressions like this. The way that this gets translated to Java code looks a little bit odd to people who have never done programming before, and that's because in programming languages we have operator precedence. You can think of it as a table that tells the compiler when something needs to be executed. So what do you do first and what do you do next? Actually, that's one of our appendices at the end of the textbook, and I believe I posted it on our website. I just added that operator precedence chart. I got that from our book. There are multiple other ones that you can find online, and this one is exhaustive. It's got all the operators. It's really larger than we need it to be, because a lot of these operators we're probably not going to be using for quite some time, but this table shows you which operators will be executed first, which one next, and so on. So this is how binding or how powerful the different operators are. Let's go back to our example here. Multiplication, division, and remainder operators are more powerful than addition or subtraction. And that's the reason why we have to use parentheses. Like, for example, in this case, we need to add 3 to 4 times x before we divide all of that by 5. So in Java, the way we do that in Java language, we take the whole numerator, we put it inside parentheses, and then we divide that by 5. As you can see here, we continue with minus 10 times. Now, the reason we're not worried about the minus being calculated before the division or multiplication is, again, we know operator precedence. We know that multiplication and division will be calculated before the compiler calculates the subtraction. But if that's confusing, you can use more parentheses like so, just to make sure that you can visually describe exactly what's supposed to happen first, what happens next, and so on. You can use as many of these parentheses as you like. They help you enforce precedence in a certain manner. Just what I said a moment ago. So for us, we're going to be initially using multiplication, division, remainder, as well as addition and subtraction. And these three, they have equal precedence, and they're more powerful. They're more binding than these two. Okay. If you have multiple instances of the same type of operation, or of operators that are at the same level of precedence, like for example division and remainder, how does, and you're not using parentheses, how does the compiler know which one is supposed to be executed first? Well, they're evaluated left to right, so whatever comes first will get executed first, at least with these 5. Not all operations are like this, but these 5 are executed left to right. Okay. And this is a visual demonstration of how this works. If this was our original expression up here, we've got the parentheses, so the compiler is going to compute this part first before it does anything else. Then it takes care of multiplication. There's 2 of those, so it's going to do the left one first, 4 times 4. And then it's going to do the next multiplication it sees, 5 times 7. And then it moves on to addition and subtraction. All of these are at the same level, so the compiler is going to do this left to right. It starts with the first plus, takes care of that, then it does the second plus, takes care of that, and finally the subtraction. So the correct result of this expression should be 53. The compound or shortcut assignment operators, the author of our book calls them augmented assignment operators, are really just a way for you to write shortcut code, I guess. You can use these if you like them. You don't have to. They're just there for you, and you should know that they exist. So the plus equal sign is equivalent to the assignment operator with the addition. In other words, I plus equals 8 is going to get expanded into I equals I plus 8 by the compiler before it gets evaluated. Okay, so it's like adding 8 to whatever was already stored into the variable I. Division equals same thing with all the other ones, but with this example here, I divided equals 8 is the same as you take whatever was already stored into I, you divide it by 8, and then you store the result of that back into I. The C++ operators, the pre-increment and post-increment with the plus plus and minus minus, actually exist in Java as well. All of them. So this is just a summary reminding you of this. Plus plus means you add 1 to whatever was already in the variable, so you're incrementing that value, and minus minus means you're decrementing the value. The difference between pre and post incrementation and decrementation is the following. If you're doing the operator in a pre-format, you're telling the compiler that you want your incrementation or decrementation to occur first, and only then you're allowing the compiler to use the value stored in that variable. If you're doing it in post format, you're telling the compiler go ahead and use that value, whatever is already in that variable in the expression, and after you're done with calculating the expression, only then increment the value of the variable. Oh, visual demonstration of how that works. We got here new num is being set to 10 times I++. Okay, compiler is going to first use the value of I in figuring out what to assign to new num, and only then will it increment I. Plus plus I down here in the second example will ensure that I gets incremented first, and then only then will the value of I be used in the larger expression. A word about numeric type conversions. If you need, and quite often you will need to convert from one data type to another, here's the rule of thumb. Here's how that happens. If one of the operands is a double, it's the largest type of value that you can store from the primitive value types, then the other one is converted into double as well. If one of the operands is a float, the other one is converted into a float. And you continue like this, going from large to small. An example of how that takes place, over here in the first one we declare a variable d of type double, but we assign integer to it. So what happens is the compiler is going to take that integer and typecast it for you. So this is called implicit casting. It's going to turn it into 3.0 and assign that to d. Down here is the more interesting type of casting. This is where you're explicitly telling the compiler to change the data type of a variable. I know these examples aren't really very good, but we're not just learning the syntax here and what we're allowed to do with Java. You're going to see some examples of where this could actually come in handy. So if you want to store 3.0 into an integer variable, you can force the data type to be int, which means the fractional part is going to get dropped, and you'll only store the whole part into that variable. Alright. There is a section in that second chapter that talks about the software development process. The significance of that section is that it wants to draw your attention to the fact that in real life, quite often, you're not really dealing with small programming projects such as the ones that we're going to be dealing with in this class. In fact, you're going to be dealing with some large projects. You're going to be building big programs, and the whole process is not as simple as just writing down the program in an IDE of your choice. So the purpose of this section is to draw your attention to the fact that there's quite a few additional steps that are involved. In software engineering, this is a pretty good summary of how it works, summary of all the steps that are involved. You start with sort of a formal process that tries to understand the problem and documents it. It basically tells you this is where you specify what the software system needs to do. The users and designers sit together and talk about that. In the next step, you try to analyze the business process in terms of how the data flows. You try to identify the system's input and output. So the second and the third steps actually represent this IPO process, which is where you want to spell out exactly what the input is going to be, what the output is supposed to be, and exactly how you're going to get from input to output. So the system design is where you design the system components. The implementation part is the process of translating the system design into programs. This is where you're doing the actual programming. And quite often it's not going to be just a single program. Here you might be building a huge library. You might be a system of individual programs that work together. And that's not where the process ends. Once you're done with the coding, the testing part is supposed to ensure that the code meets all the requirements, specifications, and that all the bugs are gone, are weeded out. Quite often the quality assurance team here, the testing people, are different than the ones who do all the programming. and that's done on purpose. Okay, so this is where you test the program to make sure that there are no bugs in it and it works the way it's supposed to. Deployment is where you simply make the project available for use. You install it on a desktop or you install it onto the web, and it becomes available for people to use it. And then once you are done with that part, the final step is maintenance. Okay, this is where you change and improve the product. You keep maintaining it. You introduce new features, you remove bugs that the new features introduce, but the point of this is that your job doesn't stop with just deploying the product. You then have to maintain it. So that's how the real world works with computer programs, and it's a good thing that they have this section in that chapter, just to draw your attention to this fact. It's not just simple programming. A few final slides here on the character and string data type. Characters are stored using 2 bytes in Java. Okay, we use the so-called Unicode system of encoding character types. With 2 bytes, you can represent 2 to the power 16 number of values. That's 65,536, I believe. And it's a large enough table for you to be able to handle languages other than Latin. Okay, it includes the Unicode table, includes encoding for characters from the Greek alphabet, Hebrew, Arabic, or Arab. I can't really remember all of them, but it's encoding data type that allows you to store quite a few characters in addition to just the standard ASCII table. If you need to create a character variable, that would be the syntax to do it. And turns out that characters are ordered, and you can use the incrementation or decrementation operator to change the value. So here, for example, we assign lowercase a to ch. If you increment the value of ch first and then you print it, you should end up with a b on the screen, lowercase b. Special characters you can display onto the console, control characters such as the line feed, carriage return, tab, backspace, by either using an escape sequence when you're specifying the character or its corresponding Unicode. The string data type, we have an entire week dedicated to that as well. We'll be looking at how you can create and control strings. It is actually a class type, so it's not one of the primitive data types per se, but a lot of programmers treat it as such in Java. So it's so well built into the language, and it's treated in such a manner that for all intents and purposes you can consider strings to be a primitive data type. Like I said, they're not. They're implemented as a separate type of class. So when you're creating a new string, this is the syntax for assigning something to it. But you don't need any special libraries to be imported to work with strings. Okay, we did mention the Unicode format. And it's good to note that you can cast between the character data type and other numeric types. So in these 2 examples you're seeing here, I is an integer and you assign the value of character a. It's the same as taking whatever code, integer code corresponds to a, and assigning that to I. And then character c equals 97 is also a valid statement. What it's going to do is going to take 97 and it will find out what the character is that corresponds to this in the Unicode data type, and it will assign that character to C. So these are valid commands in Java. Okay, and we did see string concatenation at the very beginning, so just remember you can add strings to values and the end result is a string. Alright, and with that we wrap up our introduction to variables and basic mathematical operations in Java. Thank you very much for watching.